Yeah.
I remember.
Bailey, sit down and stop bothering people.
I'm not bothering anyone.
Diana's so bothered right now.
Yeah. No, you're not.
All right, skip number 1, look at number 2. Translations. Translations are slides. Slides are easy because it's adding or subtracting numbers because we're applying a vector to something. You smell them when I'm stepping in? So here's number 2. So, for example, going from C to C prime. A couple ways to do this. One, you could write down both the coordinates and then figure out what's going on there. Or you could say, look, I know translations are a vector. I'll just count which way I'm going and how far. I'm going to the right 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm adding 9 in the x direction. And then I'm going up 3 in the y direction. That's what that vector is right there. It's up over 9 and up 3 from here to here. Now, translations apply the same vector to all points, so that's going to be the rule for everything, which means if I write those points down, C and C prime, the difference between here and here should be 9, and here should be 3. So if I look at C, it looks like it's negative 1, 2, 3, 4, 5, 6, 7, 8. And it's up 1. Then, after applying the vector, C prime is at 1, 1, 2, 3, 4. Did I add 9 and add 3 to get there? Yes, I did. Negative 8 plus 9 is 1. 1 plus 3 is 4. That is indeed the rule. Vectors and translations can be super easy if you see it. If you don't see it, tell me now so I can teach you it in 5 seconds, and you'll feel much better. Or let this thing destroy you on the quiz, and it could have been fixed this quickly. So please tell me if you're struggling and seeing what's going on here. Yeah. Okay, we learned this last week. No, week before that, officially, but we did touch on it on Thursday. So this is negative 8, 1. That's C, right? C prime is at 1, 4. We cool with that? How did I get from here to here? Well, negative 8 plus 9 is 1. And 1 plus 3 is 4. So that's the rule. What did we do? We applied the vector 9, 3 to it. Right? 9, 3 was the vector we applied to it. And we're going to apply that for all of them. So, for instance, Calvin, I know A. Let's do D. D is at negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Comma negative 1. D prime, if I want to count it out, I can. It's negative 1, 2. And look, negative 10 plus 9 is negative 1. Negative 1 plus 3 is 2. Right? So all of those are going to have the same rule applied to them. And that's what the translation is. It's sliding everything 9 to the right and 3 up. Feeling better? Okay. Turn the page. Reflections. Ones that we can eyeball. We don't need to draw the perpendicular and all that crap because we're flipping it across really nice lines. This line right here not only is perfectly horizontal, but it is also the x-axis. When we flip it across, we know reflections work this way. If I'm 5 feet from the mirror, then mirror me is going to be 5 feet from the mirror, right? They're the same distance on both sides. The distance here between B and the mirror is 5, which means when we flip B across, it's going to be 5 from the mirror as well. 1, 2, 3, 4, 5. So there's B prime. I can do the same thing for A prime. So there's our reflected image. Again, you don't need this line here. There's the reflection. How did I know it was there? Because it should be the same on both sides, right? Now, when I flipped it across the x-axis, did I flip it horizontally or vertically? Vertically. So if it's a vertical flip, which variable is going to change? Y, because y is with the vertical. So our x stays the same, and our y changes, and it's going to change by changing its sign, right? Once we were 5 up, now we're 5 down. And when we change the sign, we negate it. Remember, negation means change the sign. Doesn't always make it negative, it just flips the sign. And if you look at it, B has coordinates of 5, 5. B prime has coordinates of 5, negative 5. We kept the same x, and we changed the y by negating it. So when we flip vertically, we change the y. Of course we do. No change in x. Hanging in there, Nelly? Okay. I can tell. I had one last night. It was awful. Let's take a look at number 5 really quickly. Are we flipping horizontally or vertically? Horizontal. The line is vertical, but we're flipping it across horizontally, right? So B is once again 5 away from the line, -5, right? So when I flip it, it's still going to be 5 away from where I'm flipping it, which puts it over here. There's B prime. C would be 3 away on this side, positive 3 on this side, so there's C prime, right? A is 1, 2, 3, 4, 5 away from here, so it's going to be 5 on this side. A prime, there's our triangle. So if you look at C, its coordinates are -3, 2. And C prime is +3, +2. Which variable changed, the x or the y? The x changed. Why did the x change? Why did the x change? Well, of course, but why is that true? Why did the y stay the same and the x change? Well, because that's what happened, right? No, look over here. Why does that make sense? Say it again. It went over the y-axis. In other words, it flipped what direction?
Left to right.
Left to right, horizontally. And which variable is with the horizontal? The x. So we flipped horizontally. So of course the x is what changed. Notice that B and B prime both are the same height off the x-axis, right? The height didn't change. It's where they're located left to right changed. You can try that for all the other points. Do we understand 4 and 5 and what's going on there and why they changed? That's essential if you're going to get 6. Yes? Well, originally our x was -3, and it became a +3. We wrote a negative x here because this guy's sign changed. Remember, when we negate something, it doesn't mean make it negative. This is a prime example of that. Did this become negative? No, it did not. We negated it. When you negate a number, it means change the sign. Why is that? Because a -3 plugged in for here would be a -3, which is positive. The y stayed the same. If that was a -2 there, Calvin, if I plugged in -2 for y, I'd still get -2, right? This is the one that changed. This one did not. So we kept this the same. See how it was y before? It's still y. This was regular x before. Now it's negative version of x. The negative version of -3 is +3. Better? Excellent question. How are we feeling? Landry, doing okay? All right. Moving on to number 6. Here's what we're going to do. We're going to flip it across this line. Now, the rule is going to be very bizarre, but I'll show you what it means. So notice that A is 3 away from the line of reflection. Not the axis, but the line of reflection, right? It's 3 away. So when I flip it, it should be also 3 away on this side, right? Which puts it right on top of where D used to be. Coincidence, right? Just happened to be 3 on both sides. The line of reflection is going right down the middle. D is 3 away from the line of reflection. So when I flip it, it's going to be 3 away on the other side, which again puts it right where A would be. So there's D prime. So they switch spots. Now, to be clear, if my line of reflection was here and my original image was the red, see how B is 2 away from my line of reflection? So when I flip it, it's still going to be 2 away. There's B prime, 2 away from the line of reflection. It didn't trade spots with C, right? For this example. C is 6 away from the line of, 8 away from the line of reflection. So it's going to be 8 away from the line of reflection when I flip it. So it's just a coincidence on there that they trade spots, right? They're both 3 away from the line, therefore they switch. Sometimes that's not going to happen, right? Are we cool with that? This red thing flipping to this blue thing? Okay. So that is just a coincidence. If we write down our coordinates, A from the origin. Make sure you go from the origin, not the line of reflection. Very common mistake. Go from the origin. A is 2 to the left, and 1, 2, 3, 4, 5 up. So A is 2 to the left and 5 up. Negative 2 comma 5. Do not screw up your coordinates tomorrow. Number one mistake. Make sure you're counting from the origin. Now let's do A prime. That's 1, 2, 3, 4 to the right, and 1, 2, 3, 4, 5 up. Did anybody count from the line of reflection on accident on that one? Yep, Hannah did. I do it all the time. I have to be perfect on review days, and so far I'm 0 for 2. 4 to the right, 5 up. From the origin, right? That's how we count coordinates. Are we cool with that? So what happened here? Looks like we kept the y the same, right? So our rule should be keep the y, but we're going to change the x. Now, there's a couple different things we could do here. We could add 6 to get there, or we could multiply by negative 2. Turns out both are going to be wrong. Let's look at D's coordinates. D from the origin is 1, 2, 3, 4 to the right, and 5 up. D prime from the origin is negative 2 comma 5. So if you thought, oh, negative 2 plus 6 is 4 for the top one, so I just add 6. Is 4 plus 6 negative 2? Nope, doesn't work. Maybe you thought, oh, negative 2 times negative 2 is 4. Is 4 times negative 2 negative 2? It's not. So neither of those are going to work. Here's why. We are not we are not flipping across the y-axis. We're flipping across the vertical line, but it's not the y-axis. So it's going to change things. This was for self-development last week, right? I had a slightly different problem. Let me show you what's going on here. Start out with your x and y. Now, on number 5, we had a very similar reflection, right? But it was across the origin. What was the rule for number 5? Negative xy, because we're flipping horizontally, right? So we're flipping horizontally here too. So we're going to do a horizontal flip by negating our x. So if we do that, if we apply our flip horizontally, that negates our x. So that negative 2 is going to become a what? Yep. Now, are we home yet? We're not, right? So we need another step. How do we get 2 to become a 4? Well, either we multiply by 2 or we add 2, right? Let's go down here. If I negate my x, if I do a flip, I get negative 4, yeah? What do I do to negative 4 to make it a negative 2? I add 2, right? Negative 4 plus 2. So we're adding 2, kind of like a vector, right? Kind of like a translation like we were doing on the last page. So we do our flip, and we add 2. Does that work for the top? If we flip it and add 2, we get negative 2 becomes a 2. And then if we apply that vector 2, 0, does that get us 4, 5? It does, doesn't it? So first we negate the x, and then we add 2. So how do we write that as a rule? Well, you take what you had before, and you add 2. I'm going to talk about what that means in a second. So our rule is negative x plus 2, comma y. And it works for all of them. So what does this mean? Well, the first part I think is easy to figure out, right? That negative x right there means we're flipping it horizontally, which we are doing, right? But that assumes we're flipping it across the origin. So what that first step really does is it flips it across this, which is going to get us the wrong coordinates, but we're going to adjust for that in a second. Take a look at D. From the y-axis, D is 1, 2, 3, 4 away, correct? From the y-axis. So it should end up 4 away when I apply this rule. 1, 2, 3, 4. So when we flip it across the y-axis, that's where D prime should end up. How far is it off of real D prime? How far is that off? It's off by 2, isn't it? It's off by 2. It's off by 2. Why is that? Because our line of reflection is to the right of this. So it's as if when we do this rule, it's like we flipped it using this line We said, okay, I see your line there, but that's complicated. I'm just going to flip it over the y-axis. There I am. Now what do I have to do to correct that? Add 2. Let's look at A. Here's A. How far is it away from the y-axis? 2, right? So when we do this rule, we're saying, screw your line of reflection. I'm going to flip it over the y-axis. That's easy, right? It's 2 away from the y-axis, so I flip it 2 away over here. So here's A prime. How far is that off of actual A prime? 2 to the right. So what this is screw your line of reflection. I'll just flip it over the y-axis, right? And then I'll correct by 2. Yes. Yes. So we flip it horizontally, change the x, right? And then ask yourself, how do I get from there to there? So what I would do is, if I was doing this, I'd look at B. I'd write down its coordinates. B from the origin is negative 2, 1. Everybody with me to there? Then I would write down B prime, which I know from the line of reflection is 3 away, right? So it's going to be 3 away on this side. See how it changes spots with C here? The coordinates there from the origin are 1, 2, 3, 4 to the right and 1 up. So here's how I do this. I'd write both my coordinates down for B and B prime. I can eyeball those, right? Same distance from the line of reflection. Then I'd say, how do I get there? Well, I know I'm doing a horizontal flip, so I'm going to negate the first guy, right? So I get 2, 1. What do I do to get the 2 to become a 4? I add 2. So I negate the x and add 2. And that's the rule. Quinn, how do you feel? Dees, Mark, Natalie. Okay. Bailey, I gotta give you a chance to catch up. Bailey, I think writing stuff down really does not help you at all.
No, I got it.
Okay. Do you feel good about this and what's going on?
Yeah.
Do you understand the idea? You sure? Because if you don't, that's okay.
I think I do.
I can explain it.
I think I do.
Okay. So you know that negating the x flips it horizontally, and then we add 2 to shift it over. Another way to think of that is take the 4, change it. How do I get to negative 2? Well, I add 2. So make it negative, change the sign, and then add 2. That's the rule. Cool? Right. And the reason for that, again, is that we assume a regular line of reflection, the y-axis, and then we adjust later. Same dumb thing. Yes?
So you have to put all the blue marks down.
No. All you have to do is write the coordinates and write the rule. All this over here was to show you why it made sense. I think that's the other danger when you guys write stuff down and don't listen. You just see all this crap here and you think, oh my god, that's all my answer. And I have no idea what any of it means. It's not it. All you have to do is write the coordinates and then tell me the rule. If you understand why that rule works, that'll be great because I'm going to ask you for that later. Turn the page. Rotations. I want to go through this fairly quickly, so buckle up. Don't write stuff down. R, going to B. I draw my L. I always draw the horizontal part first. Here we go. R going to B. Blue line's going this way. I'm going to turn it 180 degrees. Does it matter which way I go for 180? Counterclockwise or clockwise? No, because if I turn it clockwise, it ends up in the same spot as if I had turned it counterclockwise. Same thing. So I'm going to take this that's pointing to the right, and I'm going to turn it 90 twice, right? 180 degrees. I'm going to go this way. 190, 290s. That's 180 degrees. Which way is it pointing now? To the right. So it was pointing to the left. Now it's pointing to the right. So that blue line from R was going to the left. Now it's going to go to the right. Same distance, 6. Red line, pointing up. After I turn it 180, which way is it pointing? Down. So still attached to the blue, but pointing down, and it's 3 in length. So there is B prime. Do not write this stuff down. B appears to be at negative 6, comma 3. B prime is at 6, negative 3. What happened to the coordinates? Both were negated. X got negated. Y got negated. -6 negated makes 6. 3 negated makes -3. Are we cool with that? Why is this true? Because whenever we flip something 180 degrees about the origin, we go 2 quadrants to either the clockwise or counterclockwise direction. That's a double minus. So if I had a point here, and I rotated 180 degrees, notice both change. If I had a point here, like A, that's a negative plus, right? If I rotate 180 degrees, it's a plus minus. Both signs change. Are we cool with that? That's why that works that way. Look at number 9. Again, do not write this. From R to C, there's our L. Pointing this way. If I go 90 degrees clockwise on your paper is the direction a clock goes, this way. So if I go from here 90 degrees clockwise, that's this way for you guys. What direction is that pointing? Up. So that blue line, which is 1, 2, 3, 4, 5, 6, 7 in length, is going to point up 7. 1, 2, 3, 4, 5, 6, 7. Red line is going to be attached to that. The question is, which direction does it go? It's pointing up now. If I turn 90 degrees clockwise, for you guys, that's this way. Which way is it going to point? To the right. And it's 3 in length. So C prime is going to end up right here where my arrow is. How do you feel about that? Let's write these coordinates down. C is 7 to the left and 3 up. C prime is 3 to the right and 7 up. Now, I did this in every other class. I chose not to do it for you guys. Normally, I would screw this up on purpose and write 7, 3, because I'd count this first and that second. Very common mistake. Remember, it's 3 to the right and 7 up. We're doing coordinates here. So not only did a sign change, but what also happened? They flipped. So X and Y, Calvin, here's X, here's your Y. They changed spots. Do you see it? So X is here now and Y is here now. But we're not done because that -7 changed signs, didn't it? See how this one changed signs? So I put a negative sign in front of here. It's whatever your X was, which was -7. It's going to go here, but it's going to be the opposite sign. You dig? Okay. That's the rule. Be careful when you're doing your coordinates. A lot of you guys would write 7, 3 here because you'd count 7 and then 3. Be careful. Now, why did X and Y switch spots? Here's why. See this blue part right here? Horizontal or vertical? Which means it's an X, right? When I rotate it 90 degrees, that blue part, still the same length, but now it's going to be a Y value, isn't it? Because it's vertical. So X and Y changed. Same thing here. This used to be a Y value because it was up and down, but when I turn it, it's now horizontal. So X and Y changed spots. How do you feel? Dece? Okay. Carver. Sick. 8 and 9 have the same rule because they're the same thing. They're both 90 degrees clockwise. So the rule will be the same for both. Has to be, right? Both are about the origin. Both are 90 degrees clockwise. So they're going to be the same rule. X and Y are going to change spots. You're going to negate the second guy. Turn the page. Buckle up. Number 10. This one's been kicking everybody's butt lately. Let's see if fourth hour can pull it off. We're going to draw an L from R to B. Don't write anything down. Observe. Watch carefully. I'm going to throw a curveball, but I'm tipping my pitch, which makes it legal. So you need to catch me. R going to B. I'm drawing my L. Notice R is not the origin. So it's going to be a weird rule. We'll talk about that. Right now, let's just worry about getting the rotation done. If I'm going this direction for my blue line, pointing to your left, and I want to turn it 90 degrees counterclockwise, I go this way. Where am I pointing? Up. Call it. Counterclockwise, wrong direction. That was my counterclockwise, not yours. Let's try that again. R's pointing this way, and I'm going counterclockwise. That's this way for you guys. Which direction is it going to point? Down. Blue line points down. Good job. 1, 2, 3, 4, 5. So I'm going to go 5 down. 1, 2, 3, 4, 5. Awesome. Red line pointing up. If I go counterclockwise, for you guys, that's this way. Which way is it going to point? To the left. So from that blue line, left 4. 1, 2, 3, 4. There is B prime. All right, buckle up. Again, tipping my pitch. From the origin, 1, 2, 3, 4, 5, 6 to the left, and 3 up. That's B's coordinates. B prime is 1, 2, 3, 4 to the left and looks like 1, 2, 3, 4, 5, 6 down. Nelly, what do you mean? -6, then -4? 1, 2, 3, 4, 5, 6 to the left, and 1, 2, 3, 4 down? I don't think so. When I count my coordinates, I always start at the origin. I started from R. Don't let that happen to you. Start from the origin. B prime is 1, 2, 3, 4, 5, 6. Oh, sorry, 5 to the left. That time I just miscounted. 1, 2, 3, 4, 5 to the left, and 1, 2, 3, 4, 5, 6 down. Now we need to figure out the rule. From Friday, when this isn't the origin, we have to do something about moving this to the origin or the origin to the point. Which one do we do? You don't remember, do you? Let's try both. So, let's try going from here to here. If I move the point to the origin, what vector did I move it by? 1, 1. I moved 1 to the right and 1 up. So I applied a vector of 1, 1. We're going to do that to all our points. So we're going to take B, which is -6, 3. We're going to add 1 to both of these, right? So we get -5, 4. Slides everything to the right 1 and up 1. Cool? Now that I've got this centered on the origin, I'm going to treat it just like a normal turn. This is a 90-degree counterclockwise turn. What once was horizontal is now vertical. What once was vertical is now horizontal. So our X and Y switch spots, don't they? I also negate 1. Which one do I negate and why? The 4 or the -5? Going from here to here. Which one do I negate? The what? The X? Give me a number.
4.
The 4. So I make that a negative? Why do I make that a negative? Does the sign change? No, it does not. Sign changes here. So we're going to change the second guy. Second guy changes. +4, +5. Okay. What?
Where does the -5, 4 come from again?
-5, 4. -5, 4. We started with -6, 3. We added 1 and 1
Okay.
from moving this.
Okay.
So this was our vector application, right? We moved everything by 1, 1. Then this part right here was our rotation, 90 degrees counterclockwise. Right? Counterclockwise rotation flops them and changes one of the signs. We figured out which one. It was the second one. Now we're here. Now we have to undo this slide that we did before to move it back to where it really is. And so we're going to undo that by subtracting 1 and subtracting 1. And we get 3, 4, which is not B prime. Yikes. So we tried sliding R to the origin. You want to try sliding it the other way? We're going to take the origin and move it to R. If we take the origin and move it to R, we go there by left 1, down 1. So we're sliding the origin 0, 0 to R. Let's try that. We start here. We're subtracting 1 from both. What do I get?
I'm sorry.
Then we need to apply our rotation. Flip and negate, right? So our rotation is going to be we flip it. And which one do we change? Change it to a positive 7. That's our rotation.
How do you know which one to change?
We're going from here to here, so positive to negative. They change, right? First one doesn't change, second one does. And then I'm supposed to undo this. How do I undo that? Add 1, right? I get 3, 8. I'm still not right. What's going on? Where am I making the mistake? This is tough.
Mistake on purpose.
These are our two ideas, side by side, starting with negative 6, comma 3. And we said B prime was at negative 5, negative 6. Counterclockwise 90 degrees, about point R.
Shouldn't the like things be 1, 3? Or just
Here,
yeah.
why 1, 3?
Cause like the negative. Oh wait, those are different points. I'm talking about.
Hmm.
Shouldn't the points be negative?
What do you mean?
Since they're positive, shouldn't the points be like 3, 4, 3, 8?
They should be. We know they're wrong, right? They should both be negative. So that can't be it. You're right. We knew that wasn't it because we also know B prime is this. We know that by just doing our L's, right? That has to be it. The question is, what's the rule? Where did I lead you astray? This is tough. I want to give you guys a while to think about this. I'll give you a hint. This is closer to being right. We want to move 1, 1. So we want to bring our point to the origin. The first way we did it was right. So we do want to do this. Maybe you won't see why it is. But how do you make negative 5, negative 6 starting from here? What could we do differently here to make that a negative 5, negative 6 in the end? Don't flip it. Don't flip it, just negate. Okay, so we don't flip it and just negate. we can get -5, -4. Then we'd have to subtract 2. Or we could get +5, +4, and then we're really up, right? So she's saying maybe we do it this way. Maybe we don't flip at all. We add 1, right? We said that's correct. -5, 4. Then she says don't flip it, just negate. We're going to negate the second guy. And then we are going to add 2. So that's our rotation. And then we're adding 2, which gets us, subtracting 2, which gets us this by subtracting 2 from the y value. And that works, but does it make sense? Is a 90-degree rotation going to give us no flip? Mm-mm. Is subtracting 2 going to put us back where we were? Mm-mm. So it's coincidence. It works, but it's not the right thing. It's still a step in the right direction. You're thinking. What if we did this? What if we didn't negate this one, but we negated this one? Now we're here. And then we subtract 1 from both, which is what we need to do to counteract that. Oh, sorry. Math is hard. We get our answer. Bailey, do you have a thought?
Why don't you negate both?
And make this a +5? That would make us further away from our goal. Also wouldn't make sense because this changes somehow. Why do I change the first one? This is a tough question. You want to know the answer? When we rotate, we negate first, then flip. This one right here needs to be negated. Why? Because that's the one that changes. So that needs to be a -4. And then we flip it. So, oh yeah. So check it out. Here's the deal. This is the mistake you were going to make yesterday or tomorrow. You're not going to make it now. We're going to add 1 because we're moving from here to here. Yes, Bailey. So, R going to the origin. 1 to the right, 1 up. We cool with that? We move R to the origin. 1 to the right, 1 up in this case. Then we change this one because see, this changes. The second guy changes sign. Do we see that? So I get this. This is all part of our rotation of 90 degrees counterclockwise. I've made one negative, right? And now I flip the x and the y. Why do I flip the x and the y? Because once was horizontal is now vertical. And then I need to undo what I did here. How do I undo? 1 to the right, 1 up. 1 to the left, 1 down. And that's the rule. It's easy if you just follow the steps, right? But the problem is that there's multiple ways to do the steps, and it's very easy to switch up the order. And if I don't show you the wrong way to do it, you're going to find out tomorrow the wrong way to do it. And you have no idea why. Bonus points if you can figure out why we have to negate first and then flip. I mean, it works with the math, but like, why does that make sense for this? Self-development there. Again, here's what you need to do. Slide R to the origin. Apply your vector. Then you need to figure out which one changes the sign and do it. Then you need to flip them, right? X and Y switch in this case. And then undo your vector. This is the one you're going to need to study. Translations on the first page, super easy, right? Reflections on the second page, not too bad, right? Negate the X or negate the Y or negate them both. Look for what's going on, right? Check your coordinates. Reflections on the third page, kind of, right? I'm sorry, not reflections, rotations, right? Make your L's and all that stuff, that's kind of new. This is the thing that's going to kick your butt. There's going to be one of these on there. I will give you self-development for 10, 11, and 12 being completed and with answers to it. 13, 14, and 15 we discussed in class, but I did not write it down. I will give self-development for this tomorrow on the quiz.
For 13, 14.
And 15. Get it what? Another copy? Absolutely. Part of this quiz is going to be super easy. Part of this quiz is going to kick your butt. All this stuff, you can have it. Oh, that too, yes. So Calvin, all that stuff I was writing down, here it is. You have what I wrote down, everything I wrote down, okay? Third hour, no one got it. Do you know why you have to do it in that order? Like geometrically, why that makes sense?
Is that a flip forward?
I mean,
I don't know. Kind of.
solve.
I can't remember.
Best of luck explaining it tomorrow in words. Don't just turn it in, okay? Don't just do that. Do the self-development. Challenge yourself. Mark, I will fail you if you don't attempt it.
I get this stuff in front.
Thank you.
When did you guys do this?
Friday and Thursday.
I was gone both those days. I do not know how to.
You don't have to do the quiz then if you're on Thursday and Friday last week. Right, that's how it works.
I get this stuff. That stuff seems,
Yep.
this seems
Because we've done that
easy.
before. Come meet with me and we'll learn this stuff and then we'll retake the quiz after break,
I
okay?
don't know what you're doing.
I didn't know you were absent both those days.